Welcome to this explainer. Today we're unpacking a really fascinating repository that's been making some serious waves in the developer community lately, the Claude-Code-EdgeRouter. We're going to dive deep into the highly ambitious concepts behind its internal framework, known as Claude Nexus, and figure out whether your next multi-agent workflow actually needs it, or, if you're better off just looking elsewhere.
But to set the stage here, I want you to picture something for a second. What actually happens when you push a single AI agent to its absolute limit? Imagine throwing a massively complex, long-horizon analysis task at it. We're talking about auditing a giant codebase or synthesizing multi-domain research. If you've tried this, you already know exactly what happens. You hit a wall, hard. But how do we break through that ceiling? So here's our roadmap for today. We'll start with the single agent ceiling, peek inside Claude Nexus, break down its three-tier architecture, compare orchestrators to proxies, and finally go over some absolutely crucial verification steps.
Okay, let's dive into this. Section 1. The single agent ceiling, pushing Claude to the limit.
Before we can really appreciate any new solution, we have to talk about the core problems software developers are facing right now when working with the Claude Code SDK. When you run a single Claude instance against a really complex task, let's say generating a full-feature implementation, you hit a ceiling incredibly fast. First off, your token budgets just fill up rapidly. Second, a single model pass simply lacks the back-and-forth iteration that true complex reasoning actually requires. So what happens next? Well, you usually end up either over-prompting a single session, just kind of hoping it magically gets everything right, or you're forced to manually orchestrate a bunch of separate API calls yourself. It's tedious, and honestly, it just doesn't scale.
Moving right along to Section 2. Inside Claude Nexus, the proposed multi-agent solution.
So Claude Nexus is the internal name for the orchestration framework detailed in the Claude-Code-EdgeRouter repository. And the sheer ambition of this project is best captured in its own documentation. The README describes it not just as a tool, but as, quote, a cognitive ecosystem, a living network of specialized intelligences, a digital think tank. The repository envisions a framework where each member brings distinct expertise, debate is highly structured, and conclusions emerge through rigorous intellectual synthesis. It is a massive, grand vision for emergent intelligence.
So what is it exactly in practice? By definition, Claude Nexus positions itself as an orchestration layer designed to route tasks across multiple specialized Claude-powered agents. Unlike those monolithic tools where one model tries to do absolutely everything, Nexus acts more like a conductor. You define the agent roles, so maybe you have an analytical agent, a creative agent, and a strategic agent. The orchestrator then assigns the work, shares context between these specialized agents, and finally synthesizes their results into one cohesive output.
Let's move to and see how this builds in Section 3, the three-tier architecture, how EdgeRouter describes its blueprint. The framework actually describes a really sophisticated three-tier cognitive model. First up is the specialization layer, where you register domain-specific agents, and each one is configured with its own specific Claude model. Next is the orchestration layer. This is the brain of the whole operation. It handles intelligent routing decisions, manages your API rate limit budget, and persists context across different agent sessions. And finally, there is the evolution layer. This is described as a continuous feedback loop, where the outcomes of agent tasks actively influence and optimize future routing decisions.
Now, I want to highlight the prominent number 0.7 here. In the provided initialization examples, there's an agent autonomy parameter that is set directly to 0.7. This points straight to use cases like CI/CD agent pipelines, allowing for partially supervised execution. For those of you deep in the Claude ecosystem, this is remarkably similar in spirit to Anthropic's own dangerously skip permissions flag that's used for sandboxed environments. It shows the framework is aiming squarely at enterprise automation.
And this brilliantly illustrates our next point in Section 4, orchestrators versus proxies, mapping the GitHub landscape.
If you were to search the Claude-Code-Router topic on GitHub right now, you would find a really messy landscape of over 25 different repositories. To make any sense of it, we have to divide this space into two distinct categories. First, you have your proxy and rotation tools, things like ccRouter or ccRelay. These sit down at the HTTP layer. Their whole job is simply to rotate API calls across multiple Claude Max subscriptions or to switch transparently between LLM providers. They don't actually think about the logic of your task. On the flip side, you have orchestration frameworks like Claude Nexus, Crew AI, and LangGraph.
These operate higher up at the agent logic layer. They handle the actual task decomposition, the role assignment, and the result synthesis. They're managers, not just traffic cops.
But let's be super analytical for a second. The core idea of multi-agent patterns isn't strictly exclusive to third parties. The native Claude-Code SDK already features built-in agent teams. Right now, natively, one session can act as a team lead, seamlessly coordinating independent teammate sessions via shared task lists and inter-agent messaging. So, what does EdgeRouter actually claim to offer? Or rather, what does it claim to offer that the native SDK doesn't already do? The primary claims are a unified routing layer that includes OpenAI API fallback, alongside an advanced cross-agent context persistence layer.
Which brings us to Section 5, Crucial Verification Steps, the reality check.
Okay, so we've talked about all these incredible enterprise promises, the three-tier architecture, and these grand cognitive ecosystems. But now we need a massive reality check. That number is 1. Literally 1. As of the writing of the source material, the Claude-Code-EdgeRouter repository contains exactly 1 commit. There is absolutely 0 verifiable source code in the repository. The whole thing is entirely 100% just a README file.
This is a textbook example of README-driven development. It is in a pre-alpha state at best. Therefore, the absolutely crucial point is this. You have to treat everything we just discussed, the layers, the routing, the intelligence, as documented, described behavior, not confirmed working behavior. These are essentially architectural blueprints, not a finished house you can just go ahead and move your production workflows into. Because of this reality, standard security practices are paramount here. The README provides installation commands that reference an external GitHub Pages site and an unverified package. If you're evaluating this, here is your non-negotiable checklist. First, run pip index versions Claude Nexus to confirm the package actually exists on PyPy. Second, read the contents of any install script before running it. A curl pipe to shell command from an unaudited site is a massive vector for supply chain attacks. Do not run it blindly. Third, check the repository for actual activity. Look for a setup.py or a pyproject.toml file. And finally, even in their examples, verify the model parameters. The README specifies Claude 4.5 Sonnet, which you should always cross-reference with current Anthropic API documentation.
Which brings us to our final thought today. The Claude Nexus documentation paints a breathtaking picture of what the future of agent orchestration looks like, a true digital think tank. But the practice right now, it requires extreme developer caution and rigorous verification. So I leave you with this question. As you build out your complex systems, is your next multi-agent workflow ready to bet on unaudited third-party orchestration? Or is the lower-risk starting point simply leveraging the native agent teams built directly into the Claude-Code SDK? Choose your tools wisely. Thanks for joining me on this explainer, and keep building smart.